So today we're going to learn a second method for solving systems. It's called substitution. And your first question might be, why? Why like graphing? I'm good at graphing. So what I'd like you to do right now is the video is going to stop, and I'd like you to graph these two systems. We're going to use number one as a very quick review to remember how to graph systems, linear systems, and solve them. And then number two, we're going to use to answer the question, why do I have to learn substitution? So the video will stop, piece of coordinate graph paper, do these, and when you come back, we'll see the answers. Okay, so let's take a look at number one. So remember, when we're graphing, the first thing we need to do is have them in a form that is easy to graph. Sometimes, y equals mx plus b is great. Standard form can be great, but sometimes we find that it's easier to solve for y. So, if we solve and graph these, your graph should have looked like this. So we would have, for the blue line, a y-intercept of 1, and then up 2 over 1, up 2 over 1. If we add the 3x to the other side, the y-intercept would be negative 1, and we have a slope of 3, up 3 over 1, up 3 over 1, and you can see you hit the other line. Solution estimation here would be 2 comma 5. This is a dangerous one to graph because the x is so tight, it is really easy to kind of not have your lines be in the right spot. This is a really good example of using that slope until you hit the other line. But just to let you know, this is one that people will, if you just move one of the lines a little bit, you can be off. And if I check my solution in both, it does work. So again, I think in this case, it was easier to put this one in y equals mx plus b by adding the 3x, and it would have been y equals 3x minus 1. There's our graphs, our solution, our checks. Still not convinced we need another method, Mrs. Woodruff, but I bet you started to think about it here. And you'll notice that this little dude has a big question mark over his head because it's like, wait, what? So again, sorry, if you solve this, y equals negative 5x plus 4, and you graph the two lines, which I'm going to show you on the next slide. So here is our 6 up 2 over 1. And then over here, if we subtract the 5x, the y-intercept would be 4 and down 5 over 1. And you can see that you cannot get these two lines to meet in the crosshairs. They don't. So your solution is really a guess at this point. And so I don't know, did you make a guess? Now, most kids will often go to halves or fourths. I'm going to show you the solution of this one. I'm not sure if anybody guessed that. So basically, if the two lines meet in the crosshairs, graphing is wonderful. However, when you start solving a system, you don't know if it's going to meet in the crosshairs. So graphing is really the solution, or the system, the process, I should say, that I use the least, because I don't know if I'm going to get some answer like this. When do I use graphing? I'll be 100% honest, if I've got technology to do it for me. And so we will learn how to do graphing and solving systems on the graphing calculators, but that'll be a ways down the road. So we need another system to sort of catch those ones where we have a weird answer. Now I'm going to be honest, we're going to do substitution. And as we go through here, however, most of the answers are going to come out to nice numbers, integers. And you're going to say, hey, I could have graphed this one. I'm trying to make the math easy. We're going to use easier ones as we go through here. All right, so here is how we use substitution. And I want you to think of substitution exactly as like a substitute teacher, where somebody would leave the room and somebody takes their place, okay? So basically up here is an example, and I'm going to show you a most complicated one right off the bat, just to show you it requires all the steps. So I've got the steps listed here. So the first thing we need to do is to solve one of the equations for one of its variables. It does not have to be y, okay? So I look around here and I'm going to solve the top one for x, and I'm going to do that by adding 2y to both sides. And are you okay with that? So the first verb is to solve. The second verb is to substitute. So we're going to go into the other equation, which is the 3x minus y equals 0. I have it right here. And the x is going to leave, and we're going to let what x equals take its place. So the first equation we rewrote as x equals 2y minus 25. And in the second equation, we're going to take out that x that's by itself, and we're going to put in the 2y minus 25. So this is still 3x minus y equals 0, but we gave x its other name, which is 2y minus 25. The reason we did that is we now have just one variable, and we can use algebra steps from Unit 2 to solve for y, and we'll have the y coordinate. So the first thing I'm going to do is distributive property. Really important to remember to distribute to the second piece. The second thing is 6y minus y, same side, like terms, combine them, not opposite operations, same operations, same side. And now we're down to a two-step equation. Add 75 to both sides, divide by 5, and the y coordinate of where these 2 lines meet is 15. I have kids that often stop here. You only have half the answer. You still need the x coordinate. So the next thing we're going to do is substitute again. We are going to substitute, and I'm going to do it in the easy way. I'm going to substitute that 15 right in here to get the x coordinate. 2 times 15 minus 25. So I'm going to take 2 times 15, which is 30, minus 25, and the x coordinate is 5, and you always want to write your solution, if you can, as an xy pair, if the variables are x and y. So it would be 5, 15. So I'm going to check it in both equations, and remember to always use the original, so not the one that I monkeyed with. So I'm going to put the 5 and the 15 in this equation, and I'm going to put the 5 and the 15 in this equation. Number one mistake, to put them in for the wrong variable. I do the math, and it works, and so I know that those two lines meet at 5, 15. That's called substitution. So I'm now going to go back. That's the hardest case, and I'm going to go back using those same verbs, solve, substitute, substitute, check, and we're going to do some easier examples up to, getting more complicated again. So I just wanted to prove to you that the method works. There's 4 verbs. So the first one is to solve one of the equations for one of the variables. We don't have to do it. It's already done. The next thing, we're going to substitute. You kind of have a choice here. So I took out the y here in the second one, and I dropped in the 7x plus 4. So this y became 7x plus 4. Now this time, it's still an algebra equation, one variable, but we have a variable on both sides. We have the choice. So I chose to add x to both sides. Again, Unit 2, variable on both sides. And I'm down to a two-step equation. I'm going to subtract 4, divide by 8, and 0 divided by 8. The x coordinate is 0. Now you're not done. You know that the x coordinate is 0, but we don't know the y coordinate. So you're going to put the 0 in, and you really can do it in either place. So I decided to put it in the top one for x. 7 times 0 is 0, plus 4, and the y coordinate is 4. And I believe that this is my solution. Now, I'm going to be honest. Right now, you can check it in both, like we did in the last one. But you might start realizing that you're kind of doing the same math over again. So you really, with substitution, not graphing, but with substitution, you really only have to check it in the equation you didn't use here. So remember, I used the top one to get the y. So I really only have to check it in the bottom. So if I put the 0, 4, 0 in for x, and 4 in for y, and do the check, it works. Now, if that confuses you, check it in both, because if you check it in the wrong one, you might not catch a mistake. So here's another example. So here, I'm going to use my verbs again, okay? So the first one is to solve, but since the top equation is already solved, I'm already good to go. The second verb is to substitute. So I'm going to go into this second equation, and I am going to take out that y and substitute in the 3x plus 8 that it equals from that first equation. That's the substitution. And now we're back to Unit 2. We're going to do the distributive property. We're going to combine like terms on the same side. So 8 plus 12 would be 20x. And here we are at the infamous two-step equation. You're going to notice I didn't mention in the other slides, you do not have to show this next step, but you always can. I'm not counting this for points, okay? So when we subtract 32, we get 20x equals negative 20. Divide by 20, and I get x equals negative 1. So if you had the 20x plus 32 equals 12, you had the 20x equals negative 20, and then the x equals negative 1. That is a good defense of your answer. You're not done. You have the x, you need the y. So we solve, substitute, check. So we're going to substitute, and I'd be putting that negative 1 right there because that's going to be the easier equation to figure it out. You can put it in either one, but why not make your life easier? So I'm going to substitute the negative 1 in for x. I multiply, and I add negative 3 plus 8, and my solution to the system would be the negative 1 comma 5. Now remember that I use the y equals 3x plus 8 equation, right? To get that second coordinate, I have to check it in the 8x plus 4y. So you're going to see I'm only doing one check. And if that confuses you, please do both. I'm going to get a negative 8 plus 20, and sure enough, it equals 12. My solution is negative 1 comma 5. Okay, I think I'm just going to do one more example with you, example 4 here, because this one needs everything. Plus I'm also showing you that it doesn't always have to be x and y. So we're going to use substitution to solve this guy. We're going to solve, substitute, check, okay? So where is the easiest one to solve? I'm not going to solve this guy for G. But I could solve it for H, right? Or solve the bottom one. There's really two ways to start this one. So, and if we were in class, I'd have you all do it and not say anything, and half the class would solve this one for H, and half the class would solve this one for G, and we'd all get the same answer. Okay, so I chose in this case to solve the bottom one for G. So I added the 2H. Is everybody okay? So now it doesn't matter which variable I solve for. Now that I have that, I'm going to use the equation I didn't touch, and I'm going to take out that G right there and substitute what it's equal. So I'm going to take that 7, take out the G, put in the 2H plus 9, and I'm off to the races. I'm going to do my distributive property, like terms. Now subtract the 63, divide by 15, and you're going to notice it's negative 65 over 15. If you divide top and bottom by 5, you get negative 13 over 3, which is negative 4 1/3. Now here is an example of one that we would not want to use graphing, because we would not have found this H coordinate, okay? So now I have solved, substitute. So now I need to substitute again. So I'm going to take that negative 13 over 3 and substitute in for the H. So G equals 2 times negative 13 over 3 plus 9. So let me just remind you where that came from, right here. So the H left, and I'm using the improper because I have to multiply. You don't want to multiply mixed numbers. So we're going to use the improper. So now I'm going to multiply and get negative 26 over 3 plus 9. So I make 9 27 over 3 to have a common denominator. Thank goodness this cleans up a little bit nicer to 1/3. So if I was going to put it as a point, I'm putting it alphabetical. So the G and then the H. If you ever have to have two different variables, put them alphabetical. So to check this kind of a mess, I have to remember which equation I want to check it in. And remember that I used the bottom one here to get that G coordinate. So I'm going to have to do the top one. So the one with the 7, basically. So if you look here, I take 7 times the G plus H has to equal negative 2. I'm going to multiply. Thank goodness they both have the common denominator. So 7 plus negative 13 will give you negative 6 over 3. And negative 6 over 3 is negative 2, and it works. So that's just giving you kind of an idea of our substitution. Now, your question might be, as we finish today, what happens like with substitution? How do you know if the lines are parallel or if they're the same line? How do you see that since you're not graphing? So I'm just going to give you two examples here just to kind of show you how it shows up. And the minute it starts happening, you're going to remember this from previous discussions. So again, I'm going to substitute. I don't have to solve because I already have one solved. So I'm going to substitute the 3x plus 1 into this y spot. I'm going to do the distributive property. And right here, when I combine like terms, the variable goes poof, and I'm left with 0 minus 2, which is negative 2 equals 5, which isn't true. Can you already guess which case this is? Think back. So this case is a no solution. This case, if you had graphed them, would be, I'm just trying to see if I can get that to pull out. This would be parallel. Okay, let's do the same thing over here. So here, I'm going to take this equation and I'm going to solve it for y. So I'm going to do the distributive property and then add 2. So I had a little bit of a mess there. And now I have y equals 3x plus 5. So this equation, the bottom one, cleans up to y equals 3x plus 5. So I'm going to go in the top one and take out the y and drop in the 3x plus 5. I'm going to do the distributive property. And again, this variable drops out, but this time I end up with 10 equals 10. That's a true statement. This case, they are the same line, so it's infinitely many. To be honest, if you solve the top one for y, it would be y equals 3x plus 5 as well. They just have hidden it well. So special cases when solving algebraically, the variable is going to drop out. We're kind of familiar with that in the past. If you end up with a not true statement, it's going to be no solution and the lines would be parallel. And if you end up with a true statement, it will be infinitely many and the two lines would have been the same line. So basically what we're going to do is we're going to take a couple of days to practice substitution. This is the entire video. We're going to start simple and kind of do two different assignments. There will be another short little video to watch on that second day, which is not mine. It's one that I found out there just to kind of show you again substitution sort of another way. So I hope that you can get started on using this method, and I will see you in class and we'll check it out together. Have a great day.